Good day, everyone. Welcome to another wonderful section on practical physics. My name is Mr. Duro, your regular host and instructor for the class. In today's class, our focus is on optics, rectangular and triangular prism. It involves tracing of rays through triangular prism and tracing of rays through rectangular prism. So sit back while I take you through some of the mistakes and errors we encounter when performing experiments on these two apparatus. It might be quite difficult for us to demonstrate this experiment because of the distance of the camera from the paper, but I will try to put it through on some of those things you need to be careful when you are doing an experiment on glass prism, whether triangular prism or rectangular prism. So let's start from this paper. Every paper that must be used for the optics part experiment must be very clean with no traces of dirt or patches of ink or stain. Because when you're tracing using your pencil, it might be difficult, when there are all these stains and all that on the paper. Now, one of the challenges students face anytime they're performing an experiment on this is the pinning of this paper to the board. Fine, you have to turn pins, which normally they give you 4, but 4 is outrageous. 2 is okay. With 2, you can actually pin this paper to the board, and ensure that you do not place the total length or insert the total length of the pin into the paper. Just the slight displacement of the pin into the board. And the reason is that once you're done with the experiment, you'll be needed to attach this paper to your practical book. And sometimes students find it very difficult to remove these pins. And as a result, the paper gets torn in the process, which is actually not a suitable experience. So just slightly place the pin on the paper, just to hold the paper down to the board, and you're good. So that is basically one of the challenges with paper. Another challenge with paper is when you're trying to trace this prism on the triangular on the paper. At times, most students do make mistakes. Their hand to shake when they are trying to trace this triangle. It's actually not good because it's going to affect every observation you are going to make on this experiment. So ensure that your hand do not shake. Position the prism properly and move the pencil or your writing material along the prism non-stop. Some students will practically just dot 3 points on the paper, remove the prism, and then trace it and join. That is not bad. Also, if it is the rectangular prism, the students will just dot the 4 edges of the prism, remove the prism, and join it with a ruler, which is not bad actually. But ensure that the tracing is carried out correctly. If you don't do that, like I said, it's going to affect all of the observations for the experiments. So that is about a paper. Yes, another thing I notice when students are doing this experiment, all the mistakes they make is about attaching or placing these optical pins on the paper. Please ensure that the paper, the pins are well spaced along the incident ray, and avoid bending the pin when you are placing it on the board. If the board is too hard, I think it's advisable you tell your instructor or your physics teacher to replace the board for you rather than you bending, because the moment it is bent, it will be difficult for you to get the full the expected collinearity of the pins when you are tracing. So it is very important. You don't bend this pin, just place it slightly. And most of the time, do not hold it at the topmost part. Hold it at the bottom, at the base where it's touching the paper, and then you pin it down. This is to avoid the pin, bending left or bending right, or even spoiling or destroying the optical pins entirely. And it could be risky now, it could waste your time when you are performing experiments in the terminal exam or external examination. So you need to be careful when you're placing the pin on it. And then when you're tracing your point, when you're tracing your point, ensure that you do not make some mistakes as well. That's very key. Ensure you do not make mistakes to the best of your ability. Trace it neatly with a nice ruler and in accordance with the instruction given. That is very key. And also, another thing I noticed when students, the mistakes students make when they perform the experiments is when they're using the protractor. Some students actually find it difficult to read from the normal to the angle of incidence, or from the normal to the angle of refraction. The normal is not starting from 0. The normal is actually starting from 90 degrees. So, for instance, if my refracted ray falls on, let's say, 75, then I will subtract 75 from 90 to get 15 degrees. 15 degrees. Not taking it from 0 to 75. You have to know how to use a protractor very, very well, because any slight mistake from your reading will affect the entire experiment, which is key. So you have to know that as well. I think basically that is all that we need to know. But another thing that it is important for me to note here is sometimes you are expected to take about 4 or 5 readings with the same apparatus, and the same pen and on the same paper. Some students will prefer to use different papers for each of these rectangular or triangular blocks for each of the readings. That's absolutely not important. It's not as important as you tracing it neatly and all your incidences can be traced on the same outline or using the same block on just one spot, and you get it absolutely correct. You get a full marks, because what examiners look out for is evidence to show that this experiment was actually carried out by you. Even when you're using the triangular prism, you don't have to place it at 5 different positions before you can obtain your 5 readings. It's not necessary. It can just be on the spot, and then you can trace all of the incidences and the refracted ray. So basically that is all I need to know about rectangular and triangular blocks. In our subsequent class, basically the real class experience, we're going to perform an experiment on this, so you see. But all the things I've told you are actually some of the mistakes some students make when they perform their experiments on this. And then we're going to briefly look at the precautions. Of course, avoid error due to parallax when reading from the protractor or the meter rule or whichever. And then note 0 error on this instrument as well. And then ensure the pins are vertically positioned on the board before the lines are traced. And also ensure that there's enough distance between the 2 pins that are placed on the incident ray or the refracted ray, or whichever the instruction the practical is asking to carry out. Make sure that the pins are adequately spaced. There's no experimental error like using a rigid support. No, you don't need that for this kind of experiments. So I think basically that is all for, and that forms the last part of this experiment on optics. We've done quite a number on the optics techniques as well as electricity. So maybe our next experiment is likely going to be on temperature. Many thanks for listening. Once again, my name is Mr. Drew, the Evaluation Physics instructor. You can subscribe to my Instagram page, Evaluation Physics 62. You can hit me up, chat me, and ask any questions related to practical physics. Thank you for listening. Have a wonderful rest of the day. Bye bye.